Hello, everybody. I am back. Okay? I am back. Okay, so where we were just now. What was our... What was the question? I mean, where I was now. Okay, I was giving an example of how to test on what is that? A parameter, right? Okay, so my question was, if you are given a scenario like I want to know the average chicken wing all over the country, and I pick a sample, so they're gonna ask, what is this average weight all over the country? So A, probably a parameter, B is the statistic, C is the population, D is the sample, something like that, okay? So they probably won't ask you directly what is a parameter. They will never ask you that kind of question, but they will give you a scenario and let you to identify what is parameter, what is statistic, what is population, and what is sample, okay? It's all about application instead of, purely answering the definition of something, okay? Okay, one problem is that I lost all the chat histories that we've had. So can anybody, if your question haven't been answered, can you post that question once again? Thank you. So please post the question once again. Thanks. Okay, Evelyn Lee is asking how many decimal places, okay, good, places should we keep for the input questions. I mean, the question will tell you explicitly how many decimals you need to keep, okay? Oh, why it stopped? Okay, it continues. Okay, can you hear me? Yes, the question will tell you explicitly how many decimal places you need to keep, okay? Anything else you want to ask? I lost all the chat histories, so please, can you please copy and paste? Can someone copy and paste the questions that haven't been answered again from the previous live streaming? I think YouTube think of this one as a new one. So probably later on we will have two recordings altogether. One is the first recording, the other is part 2. Anyway, please ask questions, okay? No questions? Okay, some of you probably have accounting tomorrow, right? But don't worry, I think accounting will be very friendly. Come on, any other questions? I think you should have plenty of questions to ask. Okay. Yeah, I know, I can go back to history, but history. Let me see if I can see the history of our chat. Yeah, let me have a look at, okay? But first I will answer Yanran Zhao's question. While hypothesis testing population, we have known P0. Yes, P0 is our hypothesized population population proportion. So you want to know the difference between P0 and P hat. So P hat is always sample proportion, right? This is proportion. This is the proportion that you observed from a sample. So for example, if you observe 100 students, and within them 30 of them are males, so the p hat for males is 30 divided by 100. So this is what you observe from a sample. This is sample proportion. Well, p0 is a general form of your hypothesized proportion. Hypothesized proportion. So for example, if the manager claims that the proportion of male in our university is 0.4, for example, and then this 0.4 is P0. So we need to write, for example, H0 to be P equals 0.4, and H1 is P not equal 0.4, something like that. So this P 0.4 is the P0. It's our hypothesized population proportion, okay? Yes, I know. I also got confused when I first learned hypothesis testing, but just know try to understand their definition, okay? This is sample proportion, and this is hypothesized proportion, population proportion, hypothesized population proportion. And now I'll try to go back and see if I can get all those chat histories, okay? Let me try and find YouTube and see if the review session. Oh, I think. Oh, why can't we see the chat histories? Where are the chat histories? Okay, but anyway, let's forget it. Christine Shi is asking, during the exam, do we have an overview from the Aplia of how many questions we have or haven't answered? Or do we have to write down questions that we haven't answered and then go back later? Okay, that's a good question. So in your Aplia system, once you click into the question, you will see question 1, question 2, question 3, 4, 5. And to the right-hand side, there is a column with a box, and out of the marks, for example, the first question was 2 marks. So if you tried this question, when you get out, here will be a star sign over here, okay? So for example, the question 2, you don't know question 2. And so if you don't know question 2, let me see, and you can skip it and go back and try question 3. And if you try question 3 and you try question 4, you will all done that. So this is the question. Without any answer, will not have a star over here. So you can identify a question that you haven't answered over here. But if this is the huge question, for example, question 16, it was 12 marks. And you are probably unsure about some, for example, some questions, but for most of the questions you can answer. So you will still get a star sign over here. But for example, there's one blank that you haven't filled in. So in this way, if that is the case, you need to probably manually take down that in question 16, you have some blanks that haven't answered, okay? So yeah. This is how our player system works, okay? All right, any other questions? It seems like I cannot check the chat history. Why is that? But anyway, if I go to my channel, okay. Why there is no chat reviews? I think YouTube removed this function. Hello. Let's see. Anyway, okay, any other questions? How many times do we need to hit submit? How many times do we need to hit submit? What do you mean by that? I think, do we submit question one by one or submit all together when we finish all the questions? Okay, so you can save your answer, okay? So every time you finish the one question, you will save your answer. And your exam will be submitted. I think you only need to submit once, okay? Or when the time is up, all your saved works will be automatically submitted, okay? Sorry, I cannot pronounce your name, but he is asking, how can I prepare for the midterm exam? Well, if there is just one day to review, that is a good question. Okay. Come on. See. First of all, please calm down. Okay. You need to know. Even if you fail this exam, it's not the end of the world, okay? So first, calm down. And then try to go to some Aplia questions, okay, that you've done before, all right? If you've done Aplia question by yourselves, then you find it very easy. I mean, you will find the mid-semester exam very easy. And also some tutorial questions. So focus on Aplia and tutorial questions, okay? And don't pay much attention on details. So if you only have one day to go, never pay attention to details. Like, do I need to know the Chebyshev rule, or like, is it 66% or 67%? Just know the overall knowledge, okay? Let me see. Chen Steven is asking, I'm wondering, if we need to know how to calculate portfolio diversification in lecture 2B? Well, as is mentioned, everything you learned in your lectures and tutorial are examinable, okay? Yes. So Yanren Zhao is asking, does the mean of sample mean always equal to the population mean? Yes. My answer is yes. The mean of sample mean always equal to population mean. That's why sample mean is an unbiased estimator of population mean, okay? The expected value of sample mean always equal to population mean. So this makes sample mean an unbiased estimator of population mean, okay? Christine Shi is saying thank you. Okay, no worries. Chen Xiong is asking, can I write down the formulas in my Excel before attending the exam? Definitely no, you can't. Well, I would say, you can't. I mean, because this is quite unfair, right? So you can only use a blank Excel file, and the invigilator will check your Excel before your exams, okay? So you cannot write down formulas in the Excel, okay? Thank you, man. Can I ask a question in Chinese? No, you can't. Because this is still a university education environment, so you can only communicate in English, okay? Anything else? But look, is it that hard to ask a question in English? Okay, any other questions? Well, is that all? I will wait for another how many minutes? 1 minute here to see if you have further questions. So let's wait Min ZZ. Okay, a little bit about portfolio diversification. Okay, so thank you for your question, Chen Stephen. Basically, by constructing a portfolio, we are actually trying to calculate the portfolio return and the portfolio standard deviation or portfolio risk. Okay, so you will be given, for example, the expected return of stock A and expected return of stock B. Okay, so we have the expected return of first stock, expected return of second stock, and the sigma of the first stock and sigma for the second stock. And we've also got the weight of the first stock and the weight of the second stock. Okay, so basically the portfolio return, RP, P for portfolio, is given by weight A, RA, plus weight B, RB, right? And the portfolio variance is given by WA squared sigma A squared plus weight B squared sigma B squared plus 2 times weight A, weight B, the covariance between A and B. Okay, all right. So for example, we do have a covariance between A and B over here. And again, as we know, covariance can be written as the correlation multiplied by sigma A, sigma B. So if you are given correlation over here, you can also substitute it as rho AB, sigma A, sigma B. So those are the formula for portfolio diversification. And yeah, that's all. In terms of application, go to for portfolio diversification, I think there is a video, just in this channel, PLG-USYD, this channel, and if you check all the videos in history, there are two series. Episode 1 is called Portfolio Diversification, and 2 is called Normal Approximation of Binomial Probabilities. And each of them only lasts for like 10-something minutes, and you can get to know them in 10 minutes, okay? Portfolio diversification and normal approximation of binomial probabilities. I won't spend much time on that because we already have videos about that. Okay. And Ruchi is asking, could you please explain interval and ratio data? Okay, interval data is just numerical data, okay? So don't be cheated by the name interval, okay? Interval, even though it's called interval, but okay, it's just numerical data. It's like the temperature is the numerical data, right? Or your scores you get in your final exam is the numerical data. But ratio data is just the result of a ratio. For example, if in accounting you learn some ratio data, you get, for example, a return. So you get a return on asset. Okay, so this kind of ratio, this is called ratio data. Return on asset is a ratio, so it's a ratio data. A ratio is also numerical, okay, but it's just in the form of a ratio. Okay, Min ZZZ has a huge question. It's asking if the claim says that at least 75 customers rate the food good and wondering why H is equal while H is not 75 rather than smaller than 75. Is it at least? Okay, 12.76 in the textbook. Well, Christine Shi. Okay, means easy. I think if it is at least, is it at least? Can anyone? Because I don't have a textbook on hand, so can anyone just? I mean, if that is the case, I think if it is at least, the answer is wrong, okay? If it is at least 75%. This means greater or equal to 75%, right? So the null hypothesis should be P greater or equal 75%. And equal sign is here. We only put equal here. And H1 is P less than 75%. Yes, you are right. I think the answer is wrong, so don't worry. Yes, you are right. And Felicity Town kind of confused with the optimal weight of portfolio diversification. So for optimal weight, I don't think this formula is in your formula sheet, isn't it? Is it in your formula sheet? I don't think so. But optimal weight means, the optimal weight means, for example, you have a stock with a certain sigma and mu, okay? And this is stock A, and this is stock B. So you can see mu is the average, the mean return, or I can put R here, return here. And sigma is the risk, standard deviation. So if we make a portfolio between A and B, and actually the possible results when we change the different weights and the portfolio returns and risk that we can achieve is like that, okay? It's not a straight line because we can achieve some of the diversification, portfolio diversification. So the optimal weight is the weight when A and B achieve the lowest risk. Oh, sorry. Here should be the risk. Sorry. Here should be the return. Okay. Yeah, risk is here. Okay. So, sorry. Okay. So this portfolio is the optimal portfolio. And for example, the weight is, for example, 0.8 of B and 0.2 of A, okay? And this weight is called optimal weight. So this optimal weight formula is helping you determine this optimal weight to achieve the lowest risk, okay? So this is optimal weight. Christine Shi is asking, I'm referring to scatter diagram directions. What's the difference between no relationship and nonlinear relationship? Okay, so if you observe a scatter plot like this, it's just a random scatters, okay? This means no relationship. But nonlinear relationship means there probably exists some relationship, but it's not linear relationship. So it can be this kind of thing. For example, this is a quadratic relationship, right? This is nonlinear, but there are still relationships, right? So this is called quadratic relationship. It's one of the nonlinear relationship. And no relationship is just no relationship, just scatter, random scatters. Okay. Cynthia Lee is asking, hi Tony, why we use half-in formula when we calculate n, approximate or assume p equals 0.5? Yes, that is a pretty good question. As we've calculated, the sample size n is actually, the original formula is z half an alpha divided by b and then square p times 1 minus p. Now, if we know p, well, we have no point to estimate p then, right? So we must not know p, so we don't know p. So if we don't know p, but we still want some value here, what should we do? Out of the conservatism, which means we want to be conservative, anyway, it's probably something like that. Out of conservatism, we want to make the sample size as large as possible, okay? So we want to make the value of p times 1 minus p to get the maximum value. So the maximum value of p times 1 minus p is 0.25. It is when p equals 0.5 and 1 minus p equals 0.5. You can try other combinations. If it is 0.4 times 0.6, it is 0.24, right? If it is 0.3, 0.8, it is 0.2. No, 37, 0.21. And if it is 0.2 times 0.8, it's 0.16. Can you see that? So only when both of them equal 0.5 can we achieve the highest result, okay? So that's why we have 0.25 over here, and then we put this guy inside here, it becomes times 0.5. Okay, because 0 square outside is 0.25. Okay, same thing. So that's why we put p equal 0.5. We just want to get a largest sample. Okay. Teddy Xu is asking, x and y are two independent random variables. X is uniformly distributed in 0 and 3, and y is uniformly distributed in 3 and 6. What is the probability density function of x plus y? Okay, that's a pretty good question. So x and y are two independent random variables. So a uniform plus a uniform can also be a uniform. Let's see. If one is from 0 to 3 and the other is from 3 to 6, so 3 values each. And when we add them all together, first of all, the sum of two identically distributed variable is also the same distribution. So if we add them up together, the possible range is from 3. When x equals 0, y equals 3, right? So the lowest value is 3. And the largest value becomes 3 plus 6 is 9, right? So it's going to be a uniform distribution from 3 to 9. All right? Okay. So this is my answer. Okay, so probability density function. All right. So the PDF is fx equal, this is 3 to 9. So 3 to 9, this is 6 in total. So this is 1 over 6. So it's 1 over 6 in the case of x from 3 to 9, and 0 otherwise. So this is the PDF for the sum of those two uniform distributions. All right, OE, how to distinguish between overwhelming evidence and strong evidence in normal distributions. All right, actually, I answered this question before in the last hours. I think there must be something specially stated in your textbook about overwhelming evidence and strong evidence, but in your lecture slides, it didn't make this kind of distinguish. Therefore, you probably don't need to know. But if you do want to know them, read the textbook, okay? I don't have a copy of textbook on hand, but I believe if you read the textbook, you will definitely find the difference between overwhelming evidence and strong evidence, something like that. Because Aprilia question follows the textbook, okay? All right, any other questions? Oh, I become hungry again. So what about we call it an end? So I will count for another 10 seconds to call this revision session an end. All right, so 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, guys, that's all for today's online consultation sessions, and thanks for watching, and wish you the best luck in your exams. Last but not the least, there are some rumors. I've heard some rumors saying that we want to fail 50% of the students in QBUS5001. That is not true at all, okay? I mean, a teacher doesn't want to fail any of their students, okay? They want everyone to pass. but there are some students who, for example, didn't watch this consultation or start doing revision from tomorrow. And those kind of students are the ones that are more likely to fail, okay? So don't worry, you're gonna fail, okay? You are far from failure in your exams, okay? So never trust this kind of rumor, okay? Okay, QBUS5020. Yeah, I don't know QBUS5020, but you know what? Recently, I always have a dream of at night. I dreamed of some student didn't finish their mid-semester exams and they were struggled. So I felt very bad. So I really don't want to make anybody fail this unit, okay? So if you work hard, you will pass, okay? And you can get even higher marks, like 90 something, 80 something. But one tips for you is that you need to try to practice the questions in a limited time, okay? Which means with a time limit, with a time limit, all right? So my last word, practice all questions with a time limit. Otherwise, if you just do it casually without thinking very intensively, and you can solve that question. And I promise you, if I give you 4 hours for your mid-semester exam, everybody can get full mark, right? But the problem is you need to know how you can solve a problem in a very quickly way, okay? So practice more, and practice makes perfect. All right, that's all for today's live streaming consultation. Thanks for watching, and hopefully I can see you or see some of you in my tutorial next week, okay? Bye-bye.